I'm Mirko Melikas from the KIT, and I'm the PI of the CAMELS Plus project. Was also involved in a lot of work. Carlos, who was the other guy, is actually not in academia anymore, so I try my very best to present everything here. So CAMELS Plus is kind of a successor to the CAMELS-DE project, which involved various German research institutions. We tried over the course of 2 years to compile a large-scale hydrological benchmark data set for modeling. And we encountered a lot of problems connected to data processing during this time. And so we adopted an existing idea in our institute to improve the handling of data pre-processing workflows, which ended up in this pilot CAMELS Plus. So the main problem was that the first version of CAMELS-DE was built on a lot of manual script-based workflows. We had data from different state authorities. Everything was completely different and a complete mess. And so everything was kind of fragmented, heterogeneous, undocumented. And the moment we got some structure into our work, the provenance eroded over time, and it's I would say nowadays quite hard to really trace down how this data set was actually produced. And during the last few years, since this data set exists, we had a few inquiries from other ESS disciplines like forestry or ecology who wanted to build on the data set and contribute to the data set. But there's not really a common interface on how to do that. And we would again have to run through the whole workflow. So what we're trying to do was we wanted to extend and develop a standardized container-based framework, or more like a specification for scientific data processing. With that, we wanted to help help building provenance and be more transparent across the full processing chain of a data set, and especially lower the technical barrier for cross-domain collaboration. And finally, like that's the overarching goal, is to make workflows a bit more broad than just the data processing fair. And especially that's kind of a focus of this project, bridge the gap between purely technical infrastructure, which exists for every single problem that we encountered, but also the usability at the end, because not everyone involved is always capable of adopting every single solution. So we really tried to optimize the specification for minimal overhead for the scientist over technical complexity, because that was one of the things that we experienced, that if we want to get other researchers to do more work, then it should really help them, and we have to make an attempt to keep this overhead small, even if a better solution from a technical perspective might exist out there. So what is this specification? Well, the main idea was to put the workflow into a Docker container and give this Docker container a specific layout. So we have one file which has some parameters in there, which defines data input. And we chose YAML to be a good format because it's really human and machine readable. Then the runtime invocation of the Docker container gets parameterized by a JSON document. And the author, the researcher, is encouraged to add a citation file into the container, which would, for example, directly be picked up by GitHub if you decide to publish your workflow on GitHub. For authorship and citation purposes. And we have a few examples on GitHub as well, and I will go briefly over them in a few moments. So basically, it's nothing fancy. It's just the specific folder structure within the container, where we have 3 different folders, one for the actual tool, for the metadata, and then mainly 2 mount points for input data and parameterization, and for output data. And this way, I can use this container locally. I can use it in a server environment, and in theory, I can also use it in an HPC environment. Yes. And that's basically the specification itself. And over the past few years, and also within this pilot project, we now build specific core components, which are mainly additive. So you can invoke a container without any of the stuff presented on this slide, just by sticking to the specification. But these things should make your life a bit easier. On the one hand, there is an open website, which is basically the specification and the documentation that's hosted on GitHub. And then I build mainly 3 different applications here. One is a Go library that can read in the specification metadata and the parameterization and validate it. And I try to reuse this Go library all over the place so that I have a single point which is responsible for validating a specific tool. Then there is a quite small yet effective little, again, Go application, which acts more like a CLI that is compiled into the container. So it's part of the container itself. And this makes use of the library for parsing to generally validate the input before something gets run. It can generate language bindings depending on what language you want to use in your tool. So you can directly, for example, read in if you decide to use Python, read in the parameters as a data class. There are also language bindings to R and to other languages. You can export the metadata of the container. You have unified logging and so on. And the last thing that we build is a small web application where you can paste in a GitHub repository that should be compliant to the specification, and this web application will analyze this repository and also give you the possibility to export the metadata into other formats. Then that's like the core components where you're really encouraged to use them because they make your life way easier if you want to adopt this whole specification for a tool. And then there are a few things that can help you to operate tools that follow this specification. They are like an outer shell around the core. On the one hand, we have templates that you can just clone on GitHub and get directly started by implementing a tool for the languages Python, R, Node.js, Octave, MATLAB, and Jupyter. But I have to say that I personally never ever tried the MATLAB template, really, because I don't have a license. But it should work anyway. And then there are different applications that can help you to invoke a container, manage the mount points, give you a little web interface or a REST endpoint for operating your tools. If you want to build an application on top of the specification, there are 3 different ones written in Go, Python, and Node.js. So depending on which language you prefer, you have a choice here. The tool CatFlow. CatFlow is a hydrological model that's used at the KIT in our working group, and one of our PhD students has used that to really streamline the pre-processing of CatFlow, and it really helped them a lot. And another tool that's a bit more generic and not data pre-processing is like a small tool that generates HTML and JSON profile reports for tabular data. So you can basically put everything that can go into a CSV file into there, and you get like a statistical report. That's I use that from time to time for quick data overview and exploration. This converter that I mentioned earlier is also on GitHub, and I can also demonstrate it live. by simply passing in one of the templates. And as you can see, it now analyzes the whole repository. It tells you what's fine and what's not so fine. Here's, for example, a mismatch between the license file and the citation.cff. I directly can see that. And down here, I can now export this metadata if I want to by either directly copying it here or downloading the metadata. Yeah, so this application also includes metadata export for the NFDI4Earth Knowledge Hub. We are still like right at the moment working on. The Knowledge Hub metadata schema changed a little bit. I have not yet updated it. So if you want to use that, you have to wait for a few more days until I'm finished with that. So the overall idea here to get fair in practice was if you adopt these containers through the templates, you get directly the GitHub CI built in. This really helps with reusability. You can directly link GitHub to Zenodo to obtain DOIs for specific releases and versions. You can store the container in the GitHub container registry if you want to. And we try to build on metadata, on existing metadata schemas as much as possible, export to a few quite general ones, so to really improve the interoperability of the workflows. I skipped that. A few challenges that are still existing and still valid is so on the one hand, modularizing a workflow is quite some work, because it will at the end of the day there are always a few parts where it's really hard to automate that in a very general way. So for example, in our workflows in the we really have problems to automate hydrological plausibility checks. So, for example, you have to check hill slope delineations by hand. There's really no way around that, so you can't really fully automate that. And I tried to port it to the whole invocation of a Docker container into Singularity, which did not work like 100%. So also, although it's supposed there are tools which are supposed to be a drop-in replacement for Docker, they are not, and in some HPC scenarios you simply don't have Docker available. So that's also an unsolved challenge. And I mean, you have to mount the data and the output into the container, so it has to be on the same host. So I can imagine, although I never ran into this challenge myself, especially in remote sensing or stuff like that, that the data just gets too big and you might need some S3 storage, or I don't know, you need different tools chained to one another where you don't want to copy from in to output folders and so on. So we, in very general terms, we're still lacking a general strategy to handle large data sets within the workflow. Yeah, I skipped that a little bit. One thing that where we so I made a couple of presentations throughout the last year, so also before the pilot on the EGU in Vienna. Usually got quite good feedback. I know that a few other groups are adopting these specifications as well. This year we also presented the work at the Tag der Hydrologie and the EGU, and we are currently preparing a manuscript that will be submitted to computers and geoscience. Yeah, and you find everything available. I skipped that as well on the on our GitHub organization. So maybe very quickly, what is still missing? It would be great to find more tools getting adopted, to get feedback from people outside of our sphere. But I also think like, okay, we build very much of the infrastructure on top of GitHub. So it would be great to have an alternative here. And then not only Carlos, but us, but also myself will leave academia and KIT. I will use a few of the core components in my own software company. But what this really needs is like a long-term perspective in terms of steering and maintenance, because otherwise it will just be a specification that helps me in my day-to-day work and not really a community specification anymore. So that's that from my side. Thank you very much.